This video we review for test 3. Number 1, decide whether or not the ordered pair is a solution to the equation. The equation is x minus y equals 7. We need to determine if 1, 8 is solution of the equation or not. So we are going to plug in the first component, substitute for variable x. Second component is for y. 1 minus 8 gives negative 7. Negative 7 equals 7 is a false statement. So 1, 8 here is not a solution of the equation. Number 2, decide whether or not the ordered pair is a solution to the equation 3x minus 2y equals 10. The ordered pair is 2, negative 2. We are going to plug in 3 times x minus 2 times y equals 10. We're going to put 2 in the place of x, put a negative 2 in the place of y. 3 times 2, 6. Negative 2 times negative 4, negative 2 times negative 2, positive 4. 6 plus 4, 10. 10 equals 10. True statement. So the ordered number pair 2, negative 2 is a solution of the equation. Please feel free to pause the video and practice on your own. Number 3, complete the ordered pair for the given equation. The given equation is y equals negative 2x plus 3. We know the value of the x-coordinate of a solution is 5. We need to find the corresponding y. So we plug in x equals 5. Let's see what's the value of the corresponding y. Y equals negative 2 times 5 plus 3. Negative 2 times 5, negative 10. Plus 3, negative 7. So the corresponding y value is negative 7. The ordered pair is completed as 5, negative 7. This is the answer. Number 4, complete the ordered pair for the given equation. Similar with a previous problem. The equation is 7x plus y equals negative 26. We know the value of y is given this time. So we're going to plug in y equals negative 26 to see what's the corresponding x. 7 times x plus y is negative 26, equals negative 26. We can see both left-hand side and right-hand side have negative 26. So if we plus 26 to each side, we can get rid of the two numbers. And that gives us 7x equals 0. 7x equals 0. We divide both sides by 7. This part actually is confusing for some of you, maybe because of the 0. You still have to isolate x by dividing both sides by 7. 7 over 7 is 1. You have x equals 0 over 7 is still 0. 0 over 7 is a well-defined number. It's just a 0. So the corresponding x value is 0. The answer is 0, negative 26 after we complete the pair. Number 5, given the ordered pairs for the points labeled on the graph. So we are given points. We need to find their corresponding coordinates. A is on the x-axis. 1, 2, 3, 4, 5, 6. 6 units to the left of the origin. So A is negative 6, 0. B is in quadrant 4. 3 units to the right. 1, 2, 3, 4. 4 units below. So the coordinates of B is 3, -4. Remember, the first component is the x-coordinate. It describes the horizontal displacement of the point. The second component is the y value. It describes the vertical displacement of the point. Number 6, plot the ordered pairs on the rectangular coordinate system. So we do the other way around. You are given the ordered pair. You need to find a corresponding point. Point A, quadrant 1, because both x and y are positive. X is 4, so 4 units to the right. Y is 6, so 6 units above. This is A. Point B, -4, 3, quadrant 2. 4 units to the left, 3 units above. Number 7, use the coordinates of the indicated points to find the slope of the line. You can see clearly this straight line is horizontal. Horizontal straight line has a slope of 0. Number 8, complete ordered pairs. Then graph the equation by plotting the points and drawing a line through them. The equation is 2x plus y equals 6. So we can actually make a table. This is x, this is y. Let's see if x equals 0. We have 2 times 0 plus y equals 6. 2 times 0 is 0. Y equals 6. So the corresponding y is 6 here. And second part, given y is 0 this time. 2x plus 0 equals 6. 2x is 6. Divide both sides by 2. We have x equals 3. So the corresponding x value is 3. Part 3, we are given the x value is 4. So let's plug in x equals 4. 4 times 4 is 16. Minus 16 from both sides. Y is -10. Oops, hold up. Oh, sorry, my bad. So here is, I copied the coefficient wrong. 2x. So plugging x equals 4 plus y equals 6. 2 times 4 is 8. 8 plus y equals 6. Subtract 8 from both sides. Y equals 6 minus 8, -2. So y is -2. So the three pairs are 0, 6, 3, 0, 4, -2. And you plot the 3 points. Connect those 3 points. You will have the graph of the straight line. Number 9, find the intercepts for the graph of the equation. The equation is a straight line, x minus 3y equals 12. Finding x-intercept, we make y be 0. Then we have x minus 3 times 0 equals 12. -3 times 0 is 0, so we have x equals 12. The x-intercept is 12, 0. For y-intercept, we make x be 0. X is 0. 0 minus 3y equals 12. Divide both sides by -3. We have a y equals -4. 12 divided by -3 is -4. So the y-intercept is 0, -4. Number 10. True or false? The y-coordinate is negative in quadrants 3 and 4. In quadrant 1, both x and y are positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. Quadrant 4, x is positive, y is negative. So the statement says the points in quadrant 3 and 4 have y-coordinate negative. That is true. 11. Find the intercepts for the graph of the equation. The equation is 3x minus y equals 3. For finding x-intercept, make y be 0. So you can see if you make y be 0, and this part disappear, right? So you have 3x equals 3. Divide both sides by 3. You have x equals 1. So the x-intercept is 1, 0. For finding y-intercept, you make x be 0. If you make x be 0, that means this part gonna be 0, right? Then you have a negative y equals 3. You divide both sides by negative 1. You have a y equals negative 3. So the y-intercept is 0, negative 3. You can always pause or repeat the part. Number 12, use the coordinates of the indicated points to find the slope of the line. You can see the line is vertical. The only correct way to describe the slope of a vertical line is undefined. Number 13, use the coordinates of the indicated points to find the slope of the line. You can see the 2 points are, one is 0, 4, the other is negative 3, 0. Another way for this problem to quickly find the slope is to use slope equals rise over run. If we go from this point to this point, from the red point to the blue point, we go up. So rise is positive. We go to the right, run is positive as well. You can see we rise 1, 2, 3, 4 units. And to the right, we have 3 units. Rise is 4, run is 3. Gives you the slope equals 4 over 3. Number 14, decide whether the slope is positive, negative, 0, or undefined. If you look at the graph from the left to the right, the straight line is going down. So the corresponding slope is negative. 15. Find the slope of the line going through the given 2 points. 3-step procedure. Step 1, label the 2 points. Label this one x1, y1. Label this one x2, y2. So you have x1 is 2, y1 is 3, x2 is negative 1, y2 is 0. Step 2, copy the formula. I will give you the formula during the test. Step 3, plug in the values. Y sub 2 is 0. Use the parentheses to hold the places. Y sub 1 is 3. Denominator, x sub 2 is negative 1. X sub 1 is 2. So the numerator 0 minus 3 is negative 3. Denominator negative 1 minus 2, negative 3 as well. Negative 3 over negative 3 gives you positive 1. Number 16, find the slope of the line. The equation here is in the slope-intercept form. Y equals mx plus b is the formula for slope-intercept form. So please look at the formula, compare our equation with the formula. You can identify the value of m, which is the coefficient of x, is negative 1. So the slope is negative 1. Number 17, determine whether the graphs of the equations are parallel, perpendicular, or neither. We have 2 straight lines. Let me color them blue and green. Let's look at the blue one. The blue equation is in the standard form. You can identify a is 3, b is negative 4. So the slope by the formula negative a over b is negative 3 over b is negative 4. Negative, negative is a positive 3 over 4. For the green equation, we do the same thing. A is 4, B is 3. We plug in the formula. A is 4, B is 3. So the slope is negative 4 over 3. So let me highlight it. The blue equation has slope 3 over 4 in blue. The green equation has slope negative 4 over 3 in green. Since the two slopes are negative reciprocal of each other. In other words, the number in blue and the number in green multiply to negative 1. So by the theorem, the two straight lines are perpendicular. They are perpendicular. Number 18, we do the same thing. We have equation in blue, equation in green. For the blue equation, we identify A equals 2, B equals 3. Slope is negative A over B, so negative 2/3. For the green equation, we have A equals 4, B equals 6. Slope is negative A over B, so it's negative 4 over 6. 4 over 6 could be reduced as a negative 4 over 6 could be reduced as a negative 2 over 3. So the slope of the green equation is also negative 2 over 3. The two equations have the same slope, so they are parallel. Number 19. The first equation blue, second equation green. For the blue equation, the blue equation actually is in the slope-intercept form. So you can identify the slope is 2. That's the advantage of slope-intercept form. You can identify the slope very easily. The green equation, standard form. So we use this formula. A is 6, B is 3. Slope negative A over B is negative. A is 6, B is 3. So reduce negative 2. Green equation has a slope of negative 2. The two slopes are not the same, not parallel. The two slopes do not multiply to negative 1, not perpendicular either. So the answer is neither. Number 20. Choose the line that most closely resembles the graph of the given equation. So basically, you are graphing the line by using slope and intercept. The equation is given in the slope-intercept form. Slope is 3. You can see that as 3 over 1. So your rise is 3, run is 1. Run is 1. Y-intercept 0, negative 4. You're going to plot the y-intercept first, right here, 4 units below the origin. And then you use rise and run to locate other points on the line. Rise is 3, remember. Run is 1. You can see rise is 3, rise is 3, run is 1. So you go up 3 over 1, go up 3 over 1, go up 3 over 1 to have more points, as many as you feel comfortable. And when you have enough points, you'll connect them all. You will have the straight line. Number 21, identify the slope and the y-intercept of the line with the given equation. By the formula y equals mx plus b, you can see the equation we have here is in the slope-intercept form. Coefficient of x is negative 1, so the slope is negative 1. Constant term is 4, so the y-intercept is 0, 4. Very straightforward, not difficult at all. Number 22, graph the linear inequality. We have a 3-step procedure, remember that. Step 1, change the inequality symbol to equal sign. And we will have x minus, so this is the inequality, right? The yellow inequality. We're going to change the inequality symbol to equal sign, and we will have x minus y equals -5. That is a straight line. That straight line is the boundary line of the solution of the inequality. Graph this line. You're going to graph the line in solid because the inequality symbol is less than or equal to. So you graph the inequality, so you graph the boundary line as a solid straight line. Since the equation right now is in the standard form, you can find the x-intercept and the y-intercept. Make y be 0, x is -5. Make x be 0, y is 5. So this is the x-intercept, this is the y-intercept. Plot the 2 points. X-intercept -5, 0, y-intercept 0, 5. You connect the 2 points, you will have the boundary line. You're going to draw the boundary line solid. Step 2, find the testing point. You can see the red point, the origin, is not on the boundary. So we can use that point as the testing point. We plug in x equals 0, y equals 0 to the original inequality. Turns out we got a contradiction because 0 is not less than or equal to -5. So the origin 0, 0 is not a solution. So the solution set would be the region above the boundary line, the green region above the boundary line. All the solutions of the inequality include all the points above the straight line, also the points on the straight line, on the boundary. Number 23, decide whether the relation a function. In this relation, you can see the first 2 pairs have the same input, different outputs. Means for the same domain element 1, the machine produces 2 different outputs. So the given relation is not a function. Function only produces 1 output. 24. Use the vertical line test to determine if the graph a function. Let's draw a vertical line. You can see this vertical line cross the graph in green twice. So the graph fails the vertical line test. The graph is not a function. Because those 2 points, the 2 red points, they have the same x value, different y value. Same input, different outputs. The relation is not a function. Number 25. You are given a linear function, which is f of x equals -3x plus 5. Find f of 5. So plug in x equals 5. You plug in x equals 5. You have -3 times 5 plus 5. Multiply before addition. -3 times 5 is -15. -15 plus 5 gives you -10. So the answer is -10. Number 26. Suppose that sales of a particular brand of appliance satisfy the relationship y equals 130x plus 4800. You can see this equation is a linear equation, where y represents number of sales in year x. So x here is the year. If x equals 0, that's the very beginning, initial time. If x equals 0, then the year is 1992. So if x equals 1, you can see it's going to be 1993. If x equals 2, it is 1994, and so on. Find the number of sales in 2000. Let's think about how many years after 1992. is 2000. 8 years, right? After 1 year, 1993. After 2 years, 1994. After 8 years is 2000. So as x equals 8, the number of year is 2000. So we want to find the number of sales in 2000, means we are looking for the y value as the x is 8. So we're going to plug in x equals 8. The equation is y equals 130x plus 4800. We plug in x equals 8. You can use your calculator. Multiply first. 130 times 8. Let's see what's that. 100. 0.24. Yeah. 1040 plus 4800. And that gives you 5840. So the number of sales in 2000 as x equals 8 is 5840. Please feel free to email me with any questions. Thank you for watching.